Hi all. Today we are going to discuss about Java 8 features. Java 8 introduced a lot of features like functional interface or Lambda expression or stream APIs, a lot of functional related features, and there is a lot of improvement happen in the concurrencies like completable features, lot of IO enhancement, JDBC enhancement, and like parallel array sorting for each ordered, like string joiners, lot of utility class improvement, a lot of features. It started with Java 8. So in the coming up, we are explain or like we are detailedly looking to the some of the major features in the Java 8. First, functional interface and Lambda expression. Like what is functional interface? By definition, it's simply just like a one interface having exactly one abstract method. So what is Lambda expression? Lambda expression is a way of more concise, more clear way of implementing functional interface by using an expressions like arrow function. So it's providing morely like the clean coding and more easily understandable, more precise way of coding. For an example, here we have a interface called model interface. We just have a one abstract method only, like a method one. But if I want to call that method one, I need to implement this abstract, implement this interface, and need to call this method and override this method in my class. A lot of things I need to do just to call one simple method in the interface. So what the magic function interface is doing is, it- and along with the Lambda expression, it provides a simple way to we can define our abstract method without implementing that in the our main class or without calling using the object. We just simply defining that one method. For example, here instead of creating the main class reference, first I am going to remove this implements model interface. Now I am going to create a model interface instance with Lambda expression. Okay, I'm using the Lambda expression. I just need to S out this hello world only. So I'm defining this interface like function like this. I'm calling this ob.method. So I can now override remove the override things and all. I'm going to run it. That's all. It's printing the hello world. So like this, using the Lambda expression and the function interface, we are providing more concise way of coding. Okay. So next is the Stream API. Stream API is one of the major feature implemented in the Java 8. So it's like a package consisting of the classes, interfaces, and enums to allow functional style of operations. Like we can sort it, we can filter it, we can map it, or like we can collect it, we can convert to different formats. What and all. Stream API provide lot of operation, lot of functions, and it's perform like a lazy computation also. It's provide lot of way to handling that. So when we are talk about the Stream API, we will find a lot of means just how to explain how to use the Lambda expression and function interface in a better way when we talk about the Stream API. For an example, I'm going to use a collection interface like a simple collection like array list. Just like few integer. I need to import this classes and all. Okay, I'm going to add the few elements to this list. Okay, I can giving different numbers, just giving some 1 to 8 or 7. Okay, so now I'm going to use Stream API to perform some operations on this list. First, I'm going to print this list by each element by. So Stream API is generally implemented using this stream method. Now I can use, just imagine I need to print only the odd number in this. So I can use the filter method. Filter method accept a predicate function, predicate interface, which is a type of another function interface which will return a Boolean value. So I can see that using the lambda expression, I'm just returning only the odd numbers. So now I want to print all the numbers. So I'm using for each method. For each method also accepting a functional interfaces, which is consumer. Consumer is like consume some values and doing some operation. It's not returning anything. Okay, now I'm printing every odd number of this. I'm going to run this. Sorry. I'll add the println function to better representation. Now you can see all this in the different lines, odd number is printed. So this is the one of the uh, Stream API's use cases. It also allows a lot of other functions like, for example, sorted. Sorted will work on the default sorting of that uh, class, maybe like what are the comparable, how comparable is in the implemented in interface. So it's like ascending order. To understand the sorting, I just reverted the order of few elements. See, still it is printing in the sorted way. Now I want to display all the odd elements square square of like a square of all element way. What I can do, I can use a map function, can do a syntax. Now it will be return all the square value of the each odd numbers like that. Or so this is how the Stream API is implemented. I will go to the next feature in the Java 8, which is a collector. Collector is like a final class that extending object class. It provide reduction operations such as accumulating the elements into collection, summarizing element according to the various criteria, etc. Okay, now we can replace this for each with the collect method in the stream so that we can understand how we can use the collectors. Okay, the collectors have a lot of functions like we can convert the result to list or set or like we can group and convert to that to the map and a lot of things. Now I am going to demonstrate how we can convert to a set value. So this will return a set. Okay, I need to specify the class instead of it. Okay, now I am going to print this set. To understand the use case, I'm going to add duplicate elements to this list. So by converting to set, it should avoid all the duplicates and give me the no give me the result with non-duplicates only. So I'm going to run this. See the result, the removed all the duplicate and only seeing the non-duplicate elements. See like this is one of the use case of the collectors, and other way we can use something like the grouping group by provide a way to we can group the element. For example, I'm going to remove this map and I am giving the count of each elements in this array list. So first I am providing function dot identity so that it will provide a function to check the duplicates, and I need to get the count so I can use collectors counting method. It will return like a map. First element key will be integer and value also is integer. Okay, why the again? Here it's give long, or the counting will give a long value, it's not integer. That is the error display. Okay, now I'm going to run this. See, it should give the count of the each elements in this list. 2 is 3 and 2 is 5. All are not duplicate only. So this is the use case of the collectors. Now we are going to the optional. Optional class provide a better way to deal with the null point exception, like handling the null point exception. Let's see how we can do that. I'm just undoing to last one. Okay. Now see, I give a filter condition like in impossible function, which will give all the for all the element it will give false only. So I'm trying to create a set like that. So there is a possibility it can be null as well. So what I'm going to do, I'm using the optional class to handling the null. One of the main method of the optional is can use of nullable. They can put all in the as a parameter of this function. Okay. And now I need to change the return type of this to optional set of integer. Okay. So this set will be optional so that I can use the method in the optional for the handling the null, like there is empty, is present and all. So if the data is there, then we are giving the is present. So then only I will test out this value. Can use the option dot get to get the values. So now I am printing this. Now data is there. Another way of implementing the optional is instead of I can use like a find any or find first. If I want to get only the first one, I can use the find first. So it will be return a optional integer value. Okay. Now it will show the first one, only the first one instead of getting all the list of values. See like this. Okay, we'll go to the next feature of Java 8. With the method reference. Method reference also deal with the constraints coding, like provide a easy form of lambda expression. Each time when you are using lambda expression to just referring a method, we can replace our lambda expression with the method reference. Here is an example of the method reference. Just like we are using a for each method and we are inside the method, we are using the standard sort function so that I need a lambda expression like this, but I can more shorten this expression using the method reference like that again. Since the println is a static function, we can just instead of like this, I can just specify the method only, and with the two full colons operator, I can give like this. See, I run the file. See, it will print the just like the same result of the lambda complete lambda expression. I can shorten the code like this, or it can use for a non-static methods as well. Like just imagine I have a model interface here. OB is a model interface object. I am using like ob.method one. Um, Instead of calling like this, I can put like this ob.method one. It will print the. It will call the that method instead of specifying all the lambda expression. That's all about the method reference. Next, we'll go to one of the more important feature of the Java 8, which is default and static method in interfaces. Like we know before, Java 8 interface are only abstract method, but in the Java from the Java 8 you can give a default method and static method as well. So for example, here is a model interface. I'm trying to define a non-abstract method like method 2. Okay, I'm doing something. This will show compilation error because interface can have abstract non-abstract method. So using the Java default one, I can specify this method as a default method. Now there is no error. So what is the use case of this? Just imagine I am implementing the model interface in many places. So if I want to add no method in the this interface, I need to implement all this method in all where I am using this. But using this default method, I can provide a default implementation of that method, so I don't need to override that everywhere. Instead of I can override where I specifically want that. In addition to default method, I can also define a static method as well. So the static method, I will provide the static method like just to print just a hello only. So just like a normal static method in the class, we can use the same way in the static method in the interface as well, just for an example. So I am going to replace this as out with the static method. Okay, now it's showing error because it expects a consumer type. So I can add one argument to that. Let me print that argument. So now the error is gone. I can run this. Will show the result. Now we will go into the next feature of Java, which is a string joiner. It's nothing like opposite to the string splitting kind of things like using the delimiter. It's combine the different string. Here we can see one demonstration of it. I'm defining a string joiner with the delimiter comma. Now I am going to add few strings. I can use the string joiner to string function to print it. Let's see the result. See, it is combined with the comma. Now we'll go with the next feature, which is a parallel array sorting. You may be familiar with the arrays utility class. It have a lot of function before Java 8 as well, like a sort to sorting the array. But in the Java 8, there is a parallel sort also introduced, which is able to sorting the parallel, which can be a more optimized way of coding that. Let's move to the next feature, which is a concurrency improvement. For the concurrency, um, after the executor servers, one of the main changes in the concurrency framework is happened is using the completable future. Just like a normal future, we need to get the value, and we don't. If we get the result, we need to perform the next step and all. But the completable future is come with the additional completion logic. We can define the what need to done after we are accepting some the response, and also this is the way we have implemented the um, concurrency in the Java. So we start using this. I can use the supply async function for performing some asynchronous operations. Let's see, I'm setting some simple hello string. So after getting this value, what I should need to do, I can use the then accept function and uh, use the response coming from the callable method to do something like now I'm going to hash out this response like this. If I run this, give me hello. Just compare if it is a future, I need to give that result to the future, and I need to use the get functions and all that. Also, this completable future provide a lot of good way of handling this exception, and there's a wrap things as well. For an example, I will demonstrate that. Can use all of operator so that I can wrap multiple things together, multiple asynchronous uh, tasks together inside this. So first I will provide this as a first argument, then I can copy this, can use how many time I want, like I will provide the same with hello 1 2 3 something like that. So I'm trying to do all the things like asynchronously. Sorry, I'm missing brackets. Let's see that all the operations are performed asynchronously. So that's all. We'll move to the next feature, which is the new date and time API. There is a lot of datetime based classes which are available in the new datetime API, like whether it's a local date or local time. There is a lot of functions to handle the dates as well, like there is a add days in the local date or minus, like we can use the instance or durations. A lot of things are happening. So these are the new functions or new features in the Java 8. So thank you all.